Hi, Fernando. Great to have you at the event on May 7. Thanks for joining me for a brief interview up front.
Hello, Ralph. Thank you for inviting me.
Sure, yeah. Your full name is Fernando Dominguez Pinuaga. You're the VP for, I think, BizDev of the company Sandbox AI. You are right now in Spain, but usually in Silicon Valley. It's a Silicon Valley-based startup. How did you get to Silicon Valley? Tell us very briefly about your background, please.
Sure. Very briefly, I'm originally from Spain, but I have a French education, so I ended up studying in Paris. And somehow I joined Google in Latin America, helping Google expand products across all the continent. And I started helping with my 20% time project, some projects from Google X related to energy and that were going to transform and change the world. And I joined Google X, where new companies, new ventures are created for Alphabet. And that's how I ran into Jack Hidary and the team working on AQ, AI, and quantum technologies. And we spun out 4 years ago to launch SandboxAQ, which is the company that we're going to talk about right now.
Great. Sounds good. Yeah. So yeah, why don't we continue? Sandbox AQ. What does this stand for? Sandbox, I guess I get, but AQ, I don't know. And is it more an AI company or quantum computing or a hybrid? What are you guys doing?
Well, sandbox in Silicon Valley, we're very familiar with the term sandbox. It's where you can experiment and build new ideas in a safe environment. So we were a sandbox inside of Google X, inside the innovation lab of Alphabet. And we were experimenting with the convergence of these two massive technology rivers, that is AI and quantum technologies. This was more than 7, 8 years ago. And we knew this was a very big thing. So we were applying quantitative models of AI into quantum equations or also quantum technologies with AI. And that's how we ended up doing the applications that we do today. You have some sensors that we're using. We're doing AI simulation. We're doing at the same time cybersecurity. We start protecting for post-quantum cryptography. Now we're doing also protection for AI. It's all quantitative at the base, at the fundamental, and we use large quantitative models. That it's the base of everything that we're doing at Sandbox AQ. So the A of AQ is for AI and the Q is for quantum.
Right, right. Um, you mentioned a new class of AI called large quantitative models, LQMs. You just started hinting on that. Can you explain in layman's terms a bit more what is behind this?
Of course. So LQM stands for large quantitative model. We've seen in the last 3 years, almost 4 years now, the revolution, what's going on with AI, but almost everything that we're talking about is for the digital world, which is the LLMs, large language models, that
Mm.
have been trained on the internet information, a lot based on words. However, what we're talking about right now, when you hear NVIDIA, Jensen, and all the leaders in AI, it's the AI for the physical world. And that's what, when you merge AI with biology, with physics, with mathematics, that's when you get the large quantitative models. They are based on fundamentals, not only on words, but on quantitative data and quantitative engineering equations that we use in our day-to-day life that describes how our world behaves today. So that's what we're using. And that impacts much more the manufacturing processes, the production processes of your companies, and the GDP of the country and the entire economy of a nation.
Mhm. All right. Can you get a bit more concrete with one, two, or three examples? What the bottom line advantage is if someone uses your technology, what they can achieve with that, please?
Of course, let me share one or two examples. On simulation, for example, we've been working with our friends KU Leuven from Belgium, for example, where we've been working with them on Parkinson's disease. Or we've also been working with the UCSF with Nobel laureate Stanley Persiner on Alzheimer, trying to simulate and run the models that tells you how those small molecules are behaving to understand how these diseases evolve and how we can treat them. So to design the molecules that are going to block those diseases. We are also part of OpenFold consortium with NVIDIA and many others to try to understand how those proteins fold and interact with each other. That's just one example. We've also done uh, open source publication of AQ catalysts. So we've developed new catalyzers that are the ones that manage the chemical world so people can use them. And we keep on simulating and getting more and more value and offering to the world. Finally, on the cybersecurity side, we started with post-quantum cryptography and we ended up developing ActiveGuard, which is our encryption management software, because all the companies, all the governments need to start transitioning all their data and how they manage encryption from the classical to the one that NIST has already approved with the final algorithms that are proven to be quantum resistant. So these are just some of the areas that we're working at with customers and partners all around the globe.
Right. And you just mentioned one customer partner in Europe. I think you have also a few more, right? Not all of them are public or disclosed.
Correct. We're working with many of the banks, especially on the security side. We're working with Aramco, for example, as well with the chemistry phase for the refineries. We're working with Novonix on batteries, simulating the life expectancy of a battery. Everything that is chemistry, everything that is physics oriented can be simulated right now because we've had such a huge progress in hardware and software in the last decade that now we can simulate things that before used to take a lot of time in the physical world. Now we do it in the digital world to then bring the results to the physical world again.
Right. Just one last question, my curiosity. So it's all software-based, your solution. You did not really develop now a quantum computer or something, right, yourself. So you're using off-the-shelf hardware, I suppose. Is that correct? Or
That's a great question. We do not use quantum computers yet. We will use them once they are ready. Right now, most of the work that we do right now is with the CPUs and GPUs. Most of what
yeah.
we do. And it's software. We also do some hardware on our medical device or our navigation device, but just in the lab, most of the essence is the LQMs, the large quantitative models.
Great. Thanks so much for the brief intro. Looking forward to hearing more applications when you are in Zurich and introduce them to our audience. You take care and yeah, we'll be in touch soon again. Bye.
Thank you, Ralph. Excellent.